Welcome everyone at the Google Developers Group meetup here tonight. We are trying to live stream this meetup, but I'm still working a bit with the microphone, so if it's not working then you only have the honor of viewing it live and it won't be recorded. We'll see how far we get. It's always exciting to do something live. It's great to see so many people here tonight, as we only announced this meetup about a week ago. We were a bit anxious at the beginning, will it work? But we figured, we'll just try it and we'll see where it ends. Now this meetup is part of a 5-day festival of data technology, which is called GoDataFest. It started as a little idea, and we figured it might be nice to organize something for the data science, data engineering community in Greater Amsterdam. If we can do like a day would be nice. I didn't know that I signed up to organize a 5-day event where we highlighted a technology every day. This is a great day because this day was all about Google. So we started this morning with a Google machine learning bootcamp led by Karl Osipov. Karl, where are you here? Where's Karl? No, it's not here. He'll be with us later. He had a quite intense day, and he must be relaxing somewhere, which is something he deserved really well. Tonight we have a really great program, which I'll introduce to you shortly. I figured that we would have some proper data scientists in the room. We're doing a contest this week as part of GoDataFest. We actually have a very nice award for the winner of our little pop quiz. If you feel that you're up to it, participate via gdd.li/datascience-popquiz. And again, the winner at the end of the week will receive a nice award, which will look really good on your resume. Normally, Rakesh takes the honors of hosting the meetups. He shared some slides with me. I had to switch because obviously he only uses the Google software for that. So now we'll get to the official part of this meetup. We have two great speakers for you tonight. We have Erwin Huizenga from Google Netherlands, where he is a machine learning evangelist. Let's call it that way. And we have Constantijn Visinescu, who is Google expert at Binx.io, who were so kind to sponsor the pizzas tonight. And we even got Bart, who formerly was of Google and now is the commercial head of Binx, to wear a lederhose especially for this occasion. So we should give him a hand for that, right? And Constantijn is one of the ambassadors and big friends of GDG Cloud. So Rakesh also asked me to give him a warm hand as well. So thanks, Constantijn. These are the regular organizers, which will be with you the next meetups again. And there are a few events coming up. At the end of this month, we have FireConf, the Firebase conference in Amsterdam. And then on the 18th of November, we have a little sister of GoDataFest, which is called DevFest, Netherlands 2017. And then on the 8th of November, there's a machine learning event, which is top secret, but you'll hear more of that later. GDG Cloud wouldn't be possible without you. This is one from Rakesh's private collection. For now, enjoy the magic. Thank you very much. Enjoy. Oh yeah, some official things I need to share with you. We've discussed the pizza. We have discussed the presentations. After the presentations, the bar is open. Feel free to get a drink. We're all making long days here, so we would like to have all of you out of here at 9:30, or you have to do the dishes and help us clean. Yeah? 9:30 would be all right. 8:30, 9:30, somewhere between that time. And now it's up to Erwin for the first talk at this meetup. We're going to do the little switch trick.
Yeah, let's switch it.
You get a lot of devices from me. You hook
Here.
up your laptop.
Oh, cool.
You can put it somewhere you feel comfortable.
Is it on?
Yeah, it's
Yeah, cool. Hi, everyone. So we had a Google Day today here at GoDataDriven. So we've been talking about machine learning all day. And I have a bit of a cold, so I hope you guys are going to ask some questions so we can make it interactive. I've been hearing to myself talk for weeks now, so that gets a bit boring as well. So please do ask questions. Let me first introduce myself. My name is Erwin. I'm a machine learning specialist, expert, or whatever you want to call it at Google, at the Google Cloud side. So my role is advising customers on how they can leverage GCP to solve their machine learning problems, to use machine learning capabilities. So the first question I want to ask is, who is a data scientist, machine learning engineer, specialist, or a bit higher, please, because then it's okay. So there are some experts in the room. Okay. I'll go through some basic machine learning concepts. It's 3 slides. It's for the people who are new to machine learning, just to introduce them and get them on a certain level so we can go through the talk. I'll be talking about our machine learning capabilities on GCP, so things like Tensorflow. You probably heard about that already, CloudML, and please do ask questions. You can always add me on LinkedIn if you have questions afterwards. Just ping me a message or on Twitter or whatever, and I'll try to answer. So what I often tend to do during talks like this, and especially when I talk to also a lot of managers and who hear that machine learning is now on the top of the hype cycle, right? Everyone wants to do machine learning. It's going to solve all your problems. If you apply machine learning, then the world is a better place. That's what everyone thinks, but we know that it's different than that. I tend to put things in perspective for a bit. I know these definitions, you can argue about them, but it's just to get a general overview of what is what. So if we talk about artificial intelligence, especially within Google, we talk about making things smart. So making computers interact with humans in a human way. And to do that, you can use different techniques, of course. You can use if, then, or else rules. But you can also use machine learning techniques. So that's a part of AI. And within the AI world, we have neural networks. And especially managers ask a lot about neural networks because it's a black box for them. But it's a type of machine learning algorithm. So you probably all used it. Who worked with neural nets? Cool. Who put neural networks in production already? Ah, yeah. Cool. So this is a overview I stole from a paper I personally really like. So we'll probably be sharing the slides as well, right? So please go and read it. It's a must-read for data science people. It's about statistical modeling the 2 cultures. So data modeling versus machine learning, the 2 worlds and how they see each other, like the math and statistics world where I'm from and the computer science world on the other side that we have a lot within Google as well, and how they see machine learning, how they think about machine learning. So it's a really nice paper to read. And what we do with machine learning is basically this. We have some input variables, something happens within nature, and we get an output, right? And what we try with machine learning is we try to model nature in a certain way. So we have our input, we use machine learning to predict our output, RI. And then within machine learning, we have this different fields. And we always talk about supervised learning, where we have training data, of course, that already has the I, where we know it, the label, the target, and we have unsupervised learning. So both techniques are also used a lot at Google. You, of course, more the supervised learning problems than the unsupervised learning. But supervised learning is used a lot as well. Any questions about this for the non-data science ML people? Sorry, ML people, you have to go through this just to get the basic ready. So machine learning at Google. So when I do a lot of these talks, I get a lot of questions in how do you do machine learning at Google? Is everyone a machine learning engineer or a data scientist? So it's just like in every company we have different people, right? We have machine learning engineers who work on machine learning problem research, helping our customers also develop their machine learning capabilities. We have developers who have some machine learning knowledge, who are able to spot machine learning problems, and we have people who have no clue what machine learning is. Yes, even at Google. Yeah, that's better. Could you? I'm not sure if you can plug it in. I need to. Oh yeah, perfect. Thanks for saving me again. Does it work already? Yeah. So this was last year. You've probably seen this slide already. It's Sander talking about how we're going through this transition. So in the past, we've been focusing on getting all our applications ready for mobile. It's mobile first. Everything is going to be mobile. So now we're changing from a mobile first company to a AI first company. And what does it mean? It means that everything we do has AI, machine learning, being data-driven in its core. We've already been a data-driven company from the start, of course, because everything we do is driven by data. That goes from hiring people, to doing recommendations in YouTube, to having machine learning capabilities on Google Cloud. So everything we do is AI. And even now, what we do is we enable everyone within Google who has a technical background to be able to tackle machine learning problems. So all the developers can go through the machine learning trainings to get these skills so that we can apply them in all the different areas that we have. So the machine learning, it's everywhere. So like I said, it's in the recommendation engine of YouTube already with, for example, wide and deep learning, what we have there. It's in Translate, of course. It's in Map. One I really like is in Photos, and how we are able to recognize people in photos. So, for example, when I search in Photos, I search for myself, it's always able to find myself. It's really good. It's even in Cardboard, and people always ask, yeah, but it's a Cardboard thing. How can it be? How can it have machine learning? Now it's in the smart stitching we do for Cardboard. So no machine learning in there, but when we build it, we use machine learning. And if you look at the adoption of machine learning models, this is machine learning models in production. It goes through the roof, so it grows exponentially. I already heard it's way more than 4,000 right now. They are in production. Yes.
I'm not sure what you want me to do. Can you give an example when you implemented machine learning in your work environment? I mean, I see these products, but I was sort of interested how, like every engineer working at Google right now implements machine learning in their day-to-day job.
So that differs. That differs where it depends on where you work, right? If you're on the YouTube team and you work on YouTube, then a problem you will be solving is how to do better recommendations, or to how to get metadata out of the videos, that you can use to generate recommendations on. But we even have machine learning people on the HR side predicting who is a good candidate to interview. So that it differs per department. And on the Google Cloud side, where I'm myself, is that it's more about helping our customers apply machine learning. So if we go to a customer, they have a certain problem, we use the knowledge and technology we have to solve the problem. That's basically what we do. So there's not one answer. It's also sometimes about training the developers to spot the problem so that they can bring in the other machine learning experts to solve it, or to work together with other teams to solve it. So it differs per project.
And so it's internal and external?
Yes, internal and external. Yes. And I often get the question, what kind of models do you have in production? So that differs, of course, as well. So, but most of our models are MLPs, like multi-layer perceptrons, still 60%. LSTMs, of course, as well. and only 5% convolutional neural nets. So everyone thinks we have a lot of CNNs, but it's still only 5%. And the biggest neural network we have has more than 100 million weights. So that's so you can, if you think about that, that takes a lot of time to train, right? That model. So and this is, so we have a lot of sorry?
And what does that one do?
That's a good question. Can't tell you. No, it's a convolutional neural network. It's in the YouTube area, so that's as much as I can tell you. But this is an important thing because with machine learning problems, we have a lot of machine learning capabilities on Google Cloud Platform, and how we developed those capabilities was because we had these challenges on the consumer side, right? For YouTube, for recommendations, for example, search or translate, how to do better translation. So we had to solve those problems. And my colleague Carl was telling this. So in the past, we did some tenders to ask other companies to help us out on those problems, but no one was able to help us to solve these problems at scale. You can easily do it on your laptop, right, to solve this machine learning problem, but then doing it at scale for this many users, that's a total different problem. So we had to develop our own infrastructure there. I'm going to talk about that today on our infrastructure. So we made that infrastructure available on Google Cloud Platform to also for our customers to be used, to leverage that infrastructure. So an example of how we apply it is, for example, this translate I was told this is Russian and that the translation is correct. So maybe some Russians in the house that can confirm that. So this is where we use, for example, convolutional neural nets to recognize the language and also do some translation in the background. When you talk about research within Google, of course we have a lot of different teams that do work on internal projects, like I said earlier, and also the teams like mine that helps customers. We have the two most famous teams you probably already know is the Google Brain team. They are within the search organization, and it's headed up by Jeff Dean, and they have developed Tensorflow, so I've built Tensorflow. And then we also acquired, a couple of years ago, DeepMind. It's based in London. They also have offices in the US, and the DeepMind, it's not within Google, it's within Alphabet, so they're still doing their own thing. Also to protect our mission a bit, their focus is around solving ultimate AI. So that's the goal they have, and that's the only goal they focus on. And doing a lot of cool stuff. So normally you can go, sorry?
What is ultimate AI?
For them, ultimate AI, that's a really good question. I asked them the same question, but you get different answers, but the management has a clear view on that. But how they work nowadays, they go from problem to problem, right? First they wanted to do the AlphaGo challenge, solved it, stopped, go on to the next one. So the next one is StarCraft, playing StarCraft with reinforcement learning, and so making the world a better place. Yeah.
How are they doing on that?
Sorry?
How are they doing on that? Because it was deep learning with pure learning?
Reinforcement learning and deep learning combined, yes. Yeah, I think it's still in the beginning phase, so I'm not sure. We should ask them for the next talk, right? That would be cool. But there are those are two of the research departments within Google who do a lot of research. And TensorFlow comes from the Brain team. So, but also a DeepMind TensorFlow is of course a use. So, an example of what DeepMind did is playing Atari Breakout. So where they combined reinforcement learning and deep learning in the Q-learning algorithm. And this is where they play Atari Breakout. And at first it's not that good, but when you train for 10 minutes, it gets better when you train it longer. And the cool thing is when you train it even further, now you're going to see a cool thing, is that? And I didn't see it for the first time. But what you see is that it learns to make a tunnel. So when you get the ball behind, it's way easier to win this game, right? So I thought, oh, this one is already smarter than I am, because I'm really bad at this game. So thanks for that, deep mind. There goes my confidence. So this is an example of what is applied. But what is then the next step for AI? You probably have ideas about that as well. So what is the next step? What do you think?
Car driving.
Something we'll work on, yeah?
Yeah, I've heard that from another talk that the next step would be like a whole sort of curriculum of tests. And these grow in complexity, like a learning child.
Yeah.
And that the solution would fulfill the whole test curriculum and then get tested on a sort of progressive, but the whole learning curriculum and then get tested on a whole different curriculum and also increases the complexity.
That's a good one as well, yeah. Everyone has opinions, of course, here, and this is a personal opinion of mine, not typically of Google. Maybe it's our vision, yeah, as well. But for me, it's about auto machine learning. And what I mean about auto machine learning, when a lot of people talk about this, but they mean different things. For example, hyperparameter tuning or just normal tuning. But for me, it's about machine learning, generating machine learning models. And there's a great paper about this, so put it in here as well so you can read it. It's out there in the open. So yeah, we're working on that research as well. I think that's a pretty cool area to go into. It's also a bit scary because then my own company is going to automate me away. So thanks again for that. But I think that's a really cool thing, and that's the next step. So go read the paper. It's pretty cool. But then, of course, why we're here to talk about machine learning in the cloud. Machine learning, we all know, has been around for a long time, right? Neural networks have been around for a long time. Machine learning has been around since statistics has been around for a really long time, and that's I think the basis of everything we do in machine learning. When we talk about machine learning, I see a lot of companies struggling with this, is that they have this great data science team that solves problems, but then solve it on their laptop, and then they have difficulties with scaling the problem into an operational environment. It takes time. You need to go through certain steps. You need to learn. You need to also get help from other expertises, right? Developers or the IT people. But I really believe in that machine learning is really good in the cloud. It's made for the cloud. That's why we developed it ourselves as well, because it can help you to go from solving a small problem in a prototype to scaling it to production within seconds. And that's what I want to talk about today. So what we do on Google Cloud Platform with machine learning is we offer a lot of different capabilities there. So we have TensorFlow. It's open source. It's available for everyone. So we open source it because we think the community is stronger than what we have. So especially when you're a researcher, you want to do low-level things, TensorFlow is perfect. Going into TensorFlow later on more in depth. Who has already used it, and not the people who have attended our training today, but some of the others? Cool, that's really good to see. So last week I've done a talk at a huge Dutch company, I won't mention their name, about 300 people there, technical people, modelers and everything. And I asked them the same question, who used TensorFlow? So not even one person put up their hand. So that was the first time I ever had that. So it's good to see some people who already tried it. Then we also have capabilities for data scientists on how to take, like I said, that small project, that proof of concept to scale with Cloud ML Engine. We'll go into that as well. And we have our APIs for developers. So we have our pre-trained models behind an API. You can call the API, you get a result back. For example, to do metadata generation for images or to do translate, things like this. It's pretty cool. You can test it also on our website. Really cool to know around that is that our vision is maybe opening up the APIs a bit more so that you can train it further on specific use cases you have yourself. So also doing some cool stuff there. But today we're going to be talking about TensorFlow and Cloud ML Engine. First of all, I wanted to talk a bit about that machine learning, as we all know, is not only about the modeling part. Most of our time we spend on getting our data from databases or where it's stored, preparing it in a certain way to do the actual machine learning. This is a generic example of how best practice around how we set up our machine learning pipelines is you have your data stored somewhere. It could be in a relational database or a non-relational database or just file storage, wherever you want to have it. Then you need to do some pre-processing or feature creation around that. Constantijn is going to talk about that later on. In general, how where data is and how you can process it a bit, right? Or am I lying now? Yeah, nope. Not the feature engineering part, but more about the processing, right? No. So I'll be talking a bit more about, like I said, TensorFlow and Cloud ML Engine and how to get your model into production. And with production, what I often mean is creating an API out of it or doing batch predictions, or maybe you want to later on take it in database and do some scoring there. So we have different tools. You want to take a picture of the previous one? Yeah, of course. This one or this one? We'll wait for him.
Thank you.
You're welcome. Questions around this, or is it clear? Okay. We have different capabilities on Google Cloud to do data science. The first thing where we always start also during the training today and what we always use is Data Lab. It's a container that has a notebook in it. So you can spin up a container on Google Cloud Platform. It also has TensorFlow packaged, and that's where you can write your machine learning code if you want. You will probably all have used notebooks. The cool thing about this is that it's a container, so it's easy to spin up. Secondly, you have integrations with GPUs if needed for machine learning training. And it has integrations to, for example, BigQuery on Google Cloud or Spark on Dataproc. So you leverage those capabilities as well. So we're going to be sharing later on in the presentation, so I always try to put some code in there as well.
Yeah, I was wondering, is it possible to spin this Data Lab environment in a local machine? Or
Yes.
Yes.
Okay. You can download it from the Docker website, right, Carl? We lost him. You can download the Docker container.
Yeah, so you need to make sure you're running Docker engine local on your laptop, and then you go out, if you Google for Data Lab Docker image, it's available there on GitHub, and there are instructions on GitHub how you can download this Docker image, build it locally, and then run it on your local laptop.
But we prefer you to do it.
Yeah, I know.
No, just kidding. Do it for everyone.
I can imagine.
No, but this has always been our vision. So if you want to do it on your own machine, you can do it there as well, right? The same with TensorFlow. If you want to run it on your local environment, you can do it as well.
You have to pay for, well, I don't know how much it's the computational power.
Yeah, exactly. Yeah, that's it. So that's Data Lab. Put some code in here as well. So if you later on want to test and try it yourself, it's really easy to spin it up. You just say in your terminal, it could be your cloud terminal, Data Lab create, you give it an instance name, you attach a zone, and then it just spins up and you can connect to the GUI. If you lose connection, it will go down and you just spin it up again. And everything is still there. Also, you can spin it up with GPUs, of course, and you can scale your machine. We're adding new capabilities over time, so there are some cool stuff coming up there as well. Probably going to be talking about that next time, so go and try it. Then we have TensorFlow. TensorFlow is our graph computational framework. It's more than only a machine learning framework. So this is thing I tend to start with always. It's now the #1 machine learning framework on GitHub. It was the #5 overall, open source project. Probably Linux is one, right?
No, actually, there's a
no, is there?
MVC framework, so the model view controller framework.
Oh yeah.
From a famous social networking company that's just about it.
Carl's from the cool facts. He knows like all this stuff. Thanks. So you can contribute if you want. So please do that as well. We're always looking for good contributors. If you look at it overall, we got almost 60,000 stars. If you compare it with other frameworks, it's going through the roof. And we're really happy with that as well. If you look at the architecture of TensorFlow, this is an overview of the architecture. And the cool thing about TensorFlow, what I really like, is that it's optimized to run on our hardware, right? On the CPUs, GPUs. They run as well the TensorFlow processing units that we're working on. It's in the early release. You can deploy it on an Android or iOS device, wherever you want to. So if you want to do inference predictions there on your device, it's possible as well. If we go higher level, then we have the lower level APIs for Python, C++ front ends. It's built in C++ as well. That's, of course, because of performance. And then we have our layers. We'll show you quickly a notebook where I built a model using layers. And we have our high-level APIs, TF.estimator, Keras. You probably know already. We're integrating Keras also more in the core. I think one of the lead developers of Keras also joined Google. Also, other high-level APIs. The TF-Learn is one. That's also developed by the community, so outside of Google. We're always supporting those communities as well. And we have the CAN estimators. So those are the different layers. What is a tensor? This is an important concept about TensorFlow. A tensor is who was in the training today? A tensor is a? Let's see if they still know some.
An n-dimensional array of data.
Yes, it's an n-dimensional array of data. So here are some examples of different tensors. So a matrix, a vector, a scalar. Probably most of you will already know this. So as said before, it's a graph-based distributed computational system. What you see here are, of course, are tensors that can be, for example, or examples or labels or weights, so representations of values. And we have our graph nodes that are computation. So a matrix multiplication, for example, or an activation function. So that is a computation. And we run this graph-based system distributed. So TensorFlow does that for you. And a good thing to know, it is a lazy evaluation. So this is normally how we all know NumPy works. You have these two arrays, you add them, and then you print the result, right? It calculates right away when you run it. With TensorFlow, it works a bit differently. We first describe our graph, and later on we need to do a session run to actually run the graph. So we have these different concepts in TensorFlow. If you want to learn more about it, I'll also have some extra information at the end. We'll share the slides so you can read up on that as well. A best practice within Google around TensorFlow is to start with the estimators. So we tend, when we do a project and also when we advise customers, what we tend to tell them is that first get your machine learning pipeline working from beginning to end. So that's the pipeline we saw first. Use first the simplest model you can have, maybe one from the estimators. And then later on we have it working end to end. You can iterate through the process on maybe deploying, testing more complex models, But that's one of the, we also released a paper on best practices, so that's also in there. So my advice for you would be to start with the estimators, unless you really want to do something that's not in the estimators, or you came up with this really cool model yourself, you can use the lower level API. So it's all up to you. So the structure of an estimate, you probably recognize this from scikit-learn or maybe H2O or some other machine learning packages. So here you instantiate the model. This is where you train it. It's all in a few lines of code. So what and this is, I need to be careful here, but what I often say is it's more about describing the model than actually programming it from scratch, right? So it makes your life a bit easier, and here is how you predict as well. So you can use the code afterwards to try if you like the estimators. And you can configure it the way you like. If you don't fill in the parameters, it will start use the basics, right? We also have, so if you have run your model and you want to optimize it or debug it, we also have something that's called TensorBoard. It's a visual way of showing your graph, showing results of your machine learning model. So this is something people often forget, is TensorBoard is not working, but you need to pip install also TensorBoard, so be aware of that. So now we talked about TensorFlow. I'll talk a bit about ML engine, so how to take your TensorFlow model into production. So Cloud ML Engine, it is our platform as a solution for training and deploying machine learning models. So you can also train, of course, TensorFlow on your own machines with GPUs, but then you need to do a lot of stitching and plumbing and making sure that things work. With ML Engine, your life gets a bit easier. So the first thing you need to do is take your TensorFlow model. I need to watch time as well for a bit. Is package your TensorFlow model to make sure that you can run it on ML Engine. So we can talk all day about how to do this. We did a training today. Put in here an example, a template on how you can package your TensorFlow model to run it on ML Engine. I worked on that with a colleague, and it's on. I still need to put it on my GitHub, but it's already on his. So then you can train it locally. So you can train of course, your TensorFlow model local. So what you then do is via your gcloud command is tell it to train local. Put the output directory and tell where the training and evaluation data is. The next step then is you want to train it in the cloud. You want to leverage the power of the cloud. So what you do there is you just tell it, it's the same structure, the same way to train it in the cloud. As well, you need to describe where your training and evaluation data is. You can put it in a cloud storage, so you can put it in a bucket. And you need to specify the region you want to use. So be aware, right now ML Engine is not available in every region. It's available in Europe 1, so in Brussels. So you can use it. And that's the closest all we have. And the cool thing is with ML Engine is that you have these tiers. That's basically how much compute you have to do your training. And you can scale up the tiers you have there. So you can increase that. You have standard 1, 2, and 3, I believe, and you can also create your own tier there. So how much power you need to train your model. And of course, you can train it on GPUs. So the K80, the P100 is coming up, so be aware, not there yet. It's still in testing phase with customers. And of course, later on, don't know the date yet, it's going to be the TPUs. And that's what everyone wants to try already, our TensorFlow processing units. And the cool thing about ML Engine is that you can also do hyperparameter tuning. So you can, yes.
How about Volta?
Volta?
The newest GPU of NVIDIA after beyond.
Yeah, that's a good question. It's probably going to be on the roadmap. Not sure when, how, but yeah, I really want to see how fast the TPUs are compared to the GPUs, because it's going to be interesting as well, right? Seen some internal benchmarks, so really looking forward there as well. Not sure if you already tried them, Carl, but I haven't yet. Need to get some. Hyperparameter tuning you can do as well. We're using a Bayesian optimization there. A lot of customers often ask, should I always start with hyperparameter tuning? What I tend to advise them is first try different models, do some tuning yourself, work on your data as well, right? We discussed this during the training today as well. After you can improve your model by working on your data first, then tuning your model, and then maybe also trying other models or more complex models. And hyperparameter tuning is something that you can do later on in the process to help further increase your accuracy, for example. Again, it's just a simple configuration you do when you fire off your command. And then the last step is when you have your model, it's deploying your model into production. So you want to create an API out of it, and then you want to do your new prediction. So you want to call the API, send the data to the API, and get a prediction. Be aware that the data has to be in the same structure as how you trained your model, of course. It's expecting the same values. But it's probably not necessary to mention. But this is also a question I get a lot. Can you do incremental learning? Yes, of course. I think that's one of the strengths of TensorFlow, because you can save the state of your TensorFlow model using checkpoints. So you typically don't want to retrain your model on all new data again every time you get new data. So maybe you want to retrain it and use the current state, so the weights that you already have, and take it from there. So you can do that using incremental learning as well. Has already someone used it in TensorFlow? Cool. Happy?
Yeah.
Cool. Everyone asks about it, but no one actually does it, so it's good to see one that actually uses it. Well, give the feedback to the product managers.
Retrained Inception for an experiment.
Ah, cool.
You want to train it from scratch. So
Yeah.
that counts.
Yeah. But it's cooler when you train something from scratch and then save it to a checkpoint and then take it further from there, right? So, yeah, good to finally meet one. Just to wrap it up, because we're running out of time as well, is that we offer a lot of different things on GCP, and I know I've been talking you through this with slides, and you're all like, yeah, cool, but go and try it. Then is when you see the real power, you see the cool things. We've been working with CloudML today with TensorFlow, and we got some great feedback and reactions. I think everyone really liked it. So the coolest thing is to do projects with it, try it out, see what works, what doesn't work. There's a lot of great documentation out there, examples, YouTube videos. Coursera has a great course. Thanks for that. Data engineering. I would really, if you want to learn more about GCP, data engineering, machine learning, I would advise you to do that one, because that's really a great one. And of course, if you want to use other machine learning packages on Google Cloud, it's possible as well. If you have your data lab instance, for example, your notebook in a container, you can, of course, install scikit-learn. I think it's already installed there, probably. You can install Caffe or other packages you want to use. So it's open, it's flexible, so use whatever you want. But already a lot of cool stuff is out there. So where to start? The TensorFlow website is really good point, yeah, to start. It has a lot of information, quick starts, demos, examples. Try the estimators first. I've added a quick start for CloudML engine. You can just go through it, copy paste the code, so create a project make sure you enable, you have ML engine there. You don't need to enable it, you can just use it. And we have some cool code labs as well, and we have a lot of great examples on GitHub. So we'll be sharing the presentation, and use whatever you like and try it. And please, if you have any feedback or any questions, you can always reach out to us. And also a lot of information on Stack Overflow. A lot of our developer advocates are active on Stack Overflow, so if you post your questions, often Googlers help you, give you, take the feedback also to the product managers and things like that. So, hope I gave you a, I know it's a quick overview. I hope, hopefully it was a nice one. Thanks, got a message. Any questions? Cool? Oh yeah, there's one.
Cheeky question. Can you use the GPUs on this to do other things than machine learning?
For other things than machine learning?
Yeah, when you suppose leverage the GPUs in all ways.
That's a good question.
Repeat the question?
Yeah. Can we use GPUs for other things than matrix calculations, machine learning?
On this specific, on the Google Cloud.
They are there, so you can use them for whatever you want to use them for. So go and spin up a machine with GPUs and do whatever you want to do. That's the best answer.
You can use them for video encoding, for instance.
Yeah, but you can do it. Here we have a lot of capabilities as well. So I tend to use them for machine learning because that's my specialism. But yeah, you can use them for whatever you want. So. Other questions? Yeah.
Have you heard about Amazon Leo?
Yeah.
Would you be willing to make a comparison?
I haven't used it, so I don't know. So, have we used Amazon? Gion, right? Gillion, yeah. I saw it in a discussion somewhere in a group. I haven't looked at it, so I know it's there and I know it's popping up. But there's a lot of things popping up in machine learning. So I visit a lot of customers, and every time I visit a customer, some new package gets thrown at me, like, oh yeah, there's something new again. So there's a lot of cool things happening, but I don't know a lot about that one. Yes?
Can you talk about that hyperparameter optimization product? You assign resource budget, time budgets, you give expanded values and figures it out. I saw something about Bayesian optimization.
Yes, that's the only one we're supporting right now.
That's like a nice to have in scikit-learn, and so far it's been relegated to some side project because they can't make it fast enough. What's going on?
So ours, what I think, I've only tested it once, so maybe Carl can elaborate on that one as well, but I think it's really fast. It's really optimized for ML engine right now. It's the only one we're supporting right now. I'm not sure on the roadmap-wise if we're going to support more different techniques there as well. But this one is, because what we tend to do is, if we have one that works really well, we stick to it. So that's, yeah, it's the only one we have right now. You can test it out.
Maybe we can talk offline.
Yeah.
How much of your presentation still works if we have to be cloud agnostic? So I think Tensorflow will still work, but if the requirement is, okay, it's nice to use Google today, but maybe tomorrow we have to go to competitor X. There are certain things that I cannot use that you talked about today, but what is still cloud agnostic, so to say?
So this is a great question. This question probably I get most, and I can only, so a lot of our projects, the things we do is we do it twofold. Just like TensorFlow, we open source it, and we also offer a managed service on Google Cloud. And what we do with the managed services is that we abstract certain things away so to make your life a bit easier. So if you want to use certain things, like the example is also the MapReduce paper we released, Dremel paper, TensorFlow's out there. So we're also involved with Apache Beam and things like that. Yes, you can all work on that yourself, but then you need to do all the plumbing yourself as well. So we tend to support open source, and it's also always just portable, right? But what we do with GCP is to make your life easier, to abstract a lot of things away, and especially in the machine learning world, people really like that, so they don't want to be bothered with all the configurations for your GPUs or things like that. They want to focus on the actual building models, working with the data and stuff like that. So that is, I think, one of our strengths. And before someone else asks me this question as well, how do you compare to other competitors, right? That's basically the question you're asking as well. Is I can only talk about our strength. If you want to move compute from one to another, everyone can do compute or storage, right? But what I think we're really good at is that we have data, machine learning, AI in our DNA. We've been doing that from day one, and we've been solving a lot of big problems there, and we always have been a leader there, also open sourcing, sharing knowledge, and I think that's one of our key strengths. And that's also like what Sundar says, where I began with, is that we're an AI first company, and you see that in everything. So I think that's one of our key strengths. Yeah.
So one of the imminent dangers to machine learning in EU today is GDPR.
Yes.
Yeah. So I could develop cool machine learning models.
Yes.
But then those models might not face the production because of privacy or personal information related bottlenecks. What tools does Google right now provide me that I can immediately use to ensure that my models can see the light of day?
This is the toughest question I can get because I'm a machine learning specialist. Yeah, it's what we do around the GDPR compliance and regulations. How do we help our customers being compliant? That's basically your question, right?
Are there any tools that I can use directly? You know,
this is a really generic question. So we offer a lot of different capabilities all over the place to make sure, of course, you follow the rules and you're compliant. We're also going through these certifications to make sure that everything on the GCP platform is that, but it is a broad topic. So maybe I think it's a good idea for a next session to have, in my team there's also John Stone, is one of the security guys. He knows everything about security and GDPR. So I think he will be best also to talk about this because we're doing a lot of things around that topic. So it's not, I can't give you one answer. It's going to be a whole presentation on what we do. So it's on a technology level we do things, of course, but it's also on making sure you're compliant, so on the rule side.
Can I give an example?
Yeah, of course.
You asked a tool. We discussed with a customer last week. Constantijn was also there. I think that's a nice tool within Google Cloud, DLP, Data Loss Prevention, I believe.
Yeah.
It's a tool that sees when, for instance, a passport is being sent over by email or stored in a file, and then it automatically detects it's a passport and blocks all the critical parts of the passport picture. So that's a tool that you can use to comply on GDPR.
Yeah, and that's a great example of one thing we do, and we do on all these levels. And encryption is one. We encrypt everything that you put on GCP that you store, but also the traffic and things like that. So it's on all these different levels. But yes, we do a lot, and we have separate sessions on that. You can find a lot of information online, and there are better people who can talk about that than me before I say crazy things. Cool. Last question, then probably
Isn't that a bit dangerous of machine learning because you can make images that trick the machine learning algorithm into misspecifying and stuff?
Ooh, I don't know. Yeah, I don't know.
Cool. Thanks all.
I think should we continue straight away or take a short break? Pause, 5 minute break. Okay, we'll start again in 5 minutes.
Succes.
Ja, dank je.